Okay, so we're going to look at intersection between circle and a line. Okay, and that line could be a tangent or it could be a chord to our circle. So let's kind of start by, I suppose, establishing what each of those means. So when we have a line could touch a circle at least one point, or I suppose not at least one point, but it's going to touch the circle maybe at one point, or it could cross the circle altogether and then have 2 points of intersection, or else it just doesn't touch the circle at all. If our circle touches at one point of intersection, then it's called a tangent. So like this one on the left hand side here, only touches at one point and then goes away off. Okay, so there's only 1 point of intersection. If instead we have 2 points, what the line is formed is called a chord. Okay, a chord is any line from one side of the circle to the other. And in that way, I suppose even the diameter of a circle is technically considered to be a chord of the circle. Okay, so when we're looking at points of intersection, then that can be one of the first things that we're asked to kind of find for is maybe what is the point of intersection? Is this line a tangent? Is it a chord? And that can be one way that we do this is look at the number of points of intersection that we get, and then from that deduce whether it's just a tangent or whether it is in fact a chord, or whether it maybe does not touch the circle at all. If there's no real points of intersection, then it maybe doesn't, then it, I suppose, doesn't intersect the circle at any point at all. Now, looking even at the example here, just to kind of explain the next part, I have two equations here. One is a line, one is a circle, and this should be reminiscent of a simultaneous equation, okay, where we have one linear and one non-linear equation. Okay, so that's something we would have done back in algebra as well. So that could be somewhere that you could go first of all, maybe to just kind of brush up on that idea here. But looking at where they intersect, then we're going to take our equation of the line and we're going to rewrite that then in terms of y. So I'm going to rewrite it as y equals 7 minus 2x over 5. Okay, rewriting my equation of the line just in terms of y. And the reason I want to do that then is I'm going to sub that into my equation of the circle. Anywhere that I have y, I'm going to replace it with the 7 minus 2x over 5. And I suppose my overall goal here really is to end up with an equation that is only an x, and then solve that equation for x, and presumably end up with two possible answers for x. Okay, so x squared plus 49 minus 28x plus 4x squared over 25 minus 3x plus 49, or not 49, excuse me, we're not squaring that one as well, so just 7 minus 2x over 5. Okay, so we can multiply across by 25 there to get 25x squared plus 49 minus 28x plus 4x squared minus 75x plus 35 minus 10x equals 0. Okay, so simplifying all of this down then, I'm getting 29x squared altogether. My x is there, I have 28, I have 75, and I have 10, giving me 113 altogether, so 113x, and then in terms of my numbers, then 49 and 35 gives me 84. Okay, so we end up with a nice quadratic equation here, which is kind of what we've expected. Okay, we're expecting to have a quadratic equation. We're expecting to have two possible values for x. If I solve this quadratic here, I do get two values for x. I get x equals 1, and I get x equals 84 over 29. Just tidy it up there. X equals 84 over 29. Now that I have my two values for x, I need to use what I've set up from the start, which is that equation for y, and I'm going to sub in each of those values for x into that format there, which gives me y equals 5 over 5, which of course is just 1, and y equals 7 minus 2 times 84 over 29 all over 5. Okay, and solving that out for ourselves here. 29 all divided by 5 gives me 217. Oh, sorry, excuse me. I replaced that with 5 instead of 2 there. I think that looked a bit too big. 2 divided by 5 gives me 7 over 29. Okay, so my 2 points of intersection then are 1, 1 and 84 over 29, 7 over 29. Okay, so 2 points of intersection. So again, we're expecting that whatever the circle is with center here, this line cuts that circle then in 2 places, with those 2 points being those 2 places. Let's jump in. So we're going to kind of mix our exam questions then in between here. So the exam question, the line x plus 3y equals 20 intersects the circle at the points P and Q. Find the equation of the circle that has P and Q as diameter. Okay, so first of all, we obviously need to find the 2 points P and Q. So let's just work our equation here. X equals 20 minus 3y. Sum of that into my equation of the circle then. So anywhere that I have x here, I'm going to replace with 20 minus 3y. Minus 6 by 20 minus 3y minus 8y equals 0. So that's going to give me 400 minus 120y plus 9y squared plus y squared minus 120 plus 18y minus 8y equals 0. So that's going to give me 10y squared altogether. In terms of my y's then, let's have a look. So that's going to give me minus 110y, and numbers, I get 280. Okay, dividing across by 10 there just to make this a little bit nicer for ourselves. 28. So it's two numbers that would multiply to give me 28, but would add to give me 11. So that's going to be 7 and 4. So I get y equals 7 and I get y equals 4. Taking both of those then and subbing them into my equation for x here. Minus 3 by 7, which is going to give me minus 1. And 20 minus 3 by 4, which is going to give me 8. So I have minus 1, 7, and I have 8, 4 as my 2 points here. Okay, so one of them P, one of them Q. We can just kind of go with one of each there for P and Q. What we're looking for now is a circle which is P and Q on either side here, and them serving as the diameter, which means my center here is going to be the midpoint of those two. So center the midpoint and the radius being half the distance between them. So let's start by finding the distance between the 2 points. So that's square root of x2 minus x1 squared plus y2 minus y1 squared squared plus minus 3 squared. So 81 plus 9, which is the square root of 90. Okay, so root 90 there. And finding the midpoint then of those two is going to be, let me take this over to this side, minus 1 plus 8 over 2, and 7 plus 4 over 2 is going to be 7 over 2 and 11 over 2. Okay, so my circle here will have center 7 over 2, 11 over 2, and radius of root 90 over 2, which we can check in our calculator. Does that reduce down to anything smaller? Divided by 2, that's just 3 root 10 over 2, so not particularly nicer in any way either. So taking both of those, then subbing them in to find the equation of the circle, as was, I suppose, requested there. X minus 7 over 2 squared, y minus 11 over 2 squared equals 3 root 10 over 2 all squared. And we'll see then if squaring that reduces down to something nicer for us in terms of the equation there. So let's have a look. Oops, sorry, I keep hitting the wrong button. 3 root 10 over 2, and we're going to be squaring that answer, and it just gives me 45 over 2. Okay, and I could multiply across by 2 there as well if I wanted to, just to eliminate that fraction, but it doesn't actually give me an equation or an expression there that is much nicer. So that's first of all just equation or intersection of the circles with another line, okay? So that kind of idea that we either have a tangent point or we have a chord. Now what we want to look at now very briefly is intersection with axes. This is something that we probably get into in a little more detail a bit later, but reminding ourselves that on the x-axis y is always equal to 0, on the y-axis x is equal to 0, so that kind of I suppose comparison between the two and the fact that it's nearly opposites there. So how we use that then, we want to find where the circle intersects with the axes. We're going to sub in the appropriate value. So say in this example here, we're asked to find where the circle intersects the x-axis. So I know if the circle's on the x-axis, that would be y equals 0. So let's sub in y equals 0 here into the equation of the circle to see what the x value is that corresponds with that. So when y is 0, what is the x value? So I get x squared minus 8x plus 7 equals 0. So I get x minus 7, x minus 1 equals 0. So x equals 7 and x equals 1. Okay, so the 2 points that I have there are between 7 and 1. So I have something along these lines here. Let me actually just move that axis there a little bit. So something along those lines there, where this might be 1, this might be 7, so the length of the intersection then is just going to be 6. Okay, so the length of the intersection is 6 there. Okay, so fairly straightforward. Just another, I suppose, slight difference in terms of intersection there, more taking advantage of what we know about the axes and what we know about the coordinates then along those axis points. Looking then at, I suppose, the last section, and this is probably, I suppose, the more, one of the two most important parts for this really is intersection of two circles. So to find where two circles intersect, we're going to follow a specific pattern. So we write them in the general format that we have there. We note that for two circles to be equal each other, similar to how we would have done with two lines, if they are equal, we can set the equations equal to each other because they should be equated. And in theory, then I suppose we're really subtracting one circle from the other. And what this is going to give us is it's going to give us the equation of the common chord. And the common chord, when I have two circles here, the common chord is this line here that they have in common. Okay, so it's the chord that passes through both circles. And in some cases, that might just be a tangent. So we might have one line here and maybe they only touch at one point and they might just have a common tangent. But it's that idea, I suppose, of that generalization of the word chord. So what we'll find is the common chord, and then we need to find where that chord intersects with each of our circles then. Okay, so starting off here, find the equation of the common chord and hence find the coordinates of the point of intersection. So finding the equation of the common chord, I need to take both of my circles here. So taking the first one, x squared plus y squared minus 3x plus 5y minus 4. I'm going to subtract the other equation of the circle here, and I'm just being very careful with my signs. So I'm going to start by writing it out just with minus and then my brackets there. And what we should nearly see straight away, because of, I suppose, how we always write these equations of the circles, is that you do end up with the x squared and the y squared part kind of eliminating each other immediately. And I suppose that's how we end up then having an equation of a line plus y plus 3 equals 0. So I have 2x plus y, 2x plus y plus 3 equals 0, minus 2x plus y plus 3 equals 0. And this is my common chord. Okay, this is the common chord. So I want to find the points of intersection. I need to see where does this chord intersect with the circles. So let's rewrite this equation, 2x minus 3, subbing that into either of the circles there, so it doesn't really matter which I sub into. I'm just going to take the second one. So x squared plus 2x minus 3 squared. This is the exact same as we did in those first examples. It's the exact same as you would have done when you're finding simultaneous equations with one linear and one non-linear. So there's nothing really new kind of coming from this part. 8x minus 12 minus 7 equals 0. So I have 5x squared minus, let me see, where does this take me? Minus 12 minus 1 plus 8 is minus 5, minus 5x plus 9 minus 12 minus 7 is minus 10. I can divide across by 5 there. X squared minus x minus 2 equals 0. That's going to give me x minus 2, x plus 1. So x equals either 2 or minus 1. Subbing both of those back in then for my equation for y gives me 1 and an answer here of minus 5. So the 2 points of intersection are 2, 1 and minus 1, minus 5, which is what I was asked to find here. So just the 2 points of intersection. So let's jump in, I suppose, to some of these exam questions then under this category. So there's a few different ways to do a few of these ones as well. So we might look at, I suppose, one or two of them or kind of see where we go. And then in some cases, maybe there might be another version in the solutions that you have as well for each of these. Or if you were to look up the exam question, there might be a slightly different way to approach it as well. But looking at these two circles here, we need to show that they intersect at 2 points and then show that the tangents to C1 at these points of intersection pass through the center of C2. So first of all, we need to find this common chord and show that there are 2 points of intersection here. So let's work on that first of all. So I want to find the equation of C1 minus C2. Okay, so that's where I'm going to start with. So taking that, so x squared plus y squared minus 8x plus 2y minus 23 minus x squared plus y squared plus 6x plus 4y plus 3 equals 0. So let's kind of see where this leaves me with then. So I'll have minus 8x plus 2y minus 23. I'm counting on the fact, I suppose, that the x squared and y squared are going to really just cancel each other out there. So I'm not going to bother writing those out again to just eliminate them all together. So I'm getting minus 14x minus 2y minus 26 equals 0. Okay, and I could divide across by 2 there to get minus 7x minus y minus 13, and I could again change the signs of this 2 as well. But this is my common chord, okay? So I need to show that this common chord is going to intersect with the circles in 2 points, and then that's going to prove the first part of the question there. So rewriting this, I get y equals minus 7x minus 13, okay? Subbing that back into then either of my equations of the circle here, we'll just take the top one. So x squared plus minus 7x minus 13 squared minus 8x plus 2 minus 7x minus 13 minus 23. Okay, I'm being very careful of our signs here. So I'm getting 49x squared, let me see, 7 by 13 is 91 by 2 is 182 here. So that's plus 182x plus 169 from the 13 squared. Let's just double check that one. Yeah, lovely. Minus 8x minus 14x minus 26 minus 23 equals 0. Okay, so let's simplify all of this down then. So I get 50x squared. I get 182 minus 8 minus 14 is 160. So plus 160x, and then I have 169 minus 26 minus 23 gives me 120. Okay, plus 120 here equals 0. Okay, so I can definitely divide across here. Let's just see what we can maybe divide across by. So 50 is not going to work for us there. We can definitely do 10. So let's just do 10 and get 5x squared plus 16x plus 12 equals 0. So it's suppose two numbers that would multiply to give me 60. So I'm looking at 6 and 10 there. I'm solving my quadratic. I get my two answers for x. So I'm just going to take my two answers here. X equals minus 6 over 5 and x equals minus 2. So I have my two answers for x. I'm going to sub those back in then to find my two values for y. Okay, so I suppose here we've nearly proved in the first part, we've shown there are 2 points of intersection. Really, I suppose just going that step further to just find what those 2 points are. So y equals minus 7 by minus 6 over 5 minus 13. Let's just see where this takes us then. Minus 7 by minus 6 over 5 minus 13 is minus 23 over 5. And y equals minus 7 by minus 2 minus 13, and that's going to take me to 1. Okay, so my 2 points of intersection, minus 6 over 5 minus 25 over, or minus 23 over 5, and minus 2, 1. Okay, as my two potential points of intersection here. And we've shown then the 2 points of intersection. That is proven the first part of the question. Second part of the question, show that the tangents to C1 at these points of intersection pass through the center of C2. So what we need to do is we need to find the tangents to the first circle at these points of intersection. So we have 2 points here. So one of them, for example, could be down there. The other one then, the other one could be here. Okay, I don't really know where they are at all. So I have 2 tangents here, and I need to show that both of those tangents do cross over, and where they cross over is actually the center of the other circle. So in theory, there's a few different ways to look at it. I want to find the equation of both of these tangents and show then that the center of the second circle is on both of those lines. Okay, so just in terms of setup, let's just find for the first circle the center. So looking at the equation here, I'm looking at the coefficient of x. I know 2g is minus 8, so g is minus 4. So in terms of my center, that's minus g, so that's going to be 4. Same with y is 2, so 2f is y. 2f is 2, f is 1, so minus f is minus 1. So the center is 4 minus 1. Okay, looking at the second circle, then the center of the second circle is minus 3 minus 2. Okay, I can also find the radius of both of these as well. We're just going to see if I actually need to find the radius of both of these. So what I'm looking for is, for this circle with 4 minus 1, I need to find the equation of both of these lines that I've drawn here. So we can give them both a name. We call this one maybe T, and call this one K. So I want to find the equations of T and K. The first thing I'm going to note is that they are perpendicular to the radius at that point. Okay, they're perpendicular to the line from the center to the edge here. I know what each of these 2 points are as well. Okay, so looking at each of those, let's just say that tangent T is the one that has this line in it, and tangent K is the one that has this point in it. So using both of those points, I'm going to find the slope of the line here from 4 minus 1 to my tangent point, and then I'm going to use that to find the perpendicular slope. Okay, so let's have a look at that first of all. So finding the slope here is going to be minus 1 plus 23 over 5, and y2 minus y1 over x2 minus x1, because it's negative, it just becomes positive overall. And let's just have a look at that then in my calculator. Minus 1 plus 23 over 5 and 4 plus 6 over 5 gives me 9 over 13, which means the slope of my line T is going to be minus 13 over 9. Okay, so getting my perpendicular slope here, not the nicest slope for us to be working with, but we can kind of make do with that one. Okay, I know a point on that line as well. The point I'm going to be using is the point that we've labelled up here, the minus 6, 5. So y minus 23 over 5 minus 23 over 5 equals m, which is minus 13 over 9, x minus 6 over 5. Okay, so a lot of different signs and things going on here, so we just need to be kind of slow and steady here to make sure we don't make any mistakes. So minus 13 over 9x, this is going to be positive 6 over 5 multiplied by a minus 13 over 9. It's going to give me minus 26 over 15 here. Minus 26 over 15. Okay, I'm going to multiply across here. I'm going to multiply across by 45, the kind of lowest common denominator, or the common denominator here for these ones here. So 23 over 5 multiplied by 45 gives me 207. The minus 13 over 9 multiplied by 45 is going to give me minus 65. And the 26 over 15 multiplied by 45 gives me 78. Okay, so bringing everything together here, then 65x plus 45y and 207 plus 78 is 285. Okay, and I could probably reduce that down as well if I wanted to. So 65, let's see, well, 5 I suppose probably goes into everything there. So 13x plus 9y plus 285. Give it another one. 57. Perfect. Okay, so we can reduce it down, absolutely no call to. So let's ask ourselves then, is the center of the second circle, which is minus 3 minus 2, on line T? So reminding ourselves to test if a point is on the line, we need to see if it satisfies the equation. If it does, that means it is on the line. So 13 by 3 minus 39 minus 18 plus 57 equals 0. That is 0, so it is on that line. Okay, so we've proven that it is on that first line here. We need to show now, is it on the second line? So to do that, I need to find the slope of that second line. So we're looking again in the same format, we're following the same steps, the slope from the center to this other point, minus 2, 1. So we see y2 minus y1, x2 minus x1. So that's minus 2 over 6, so minus a third, which means the slope of my perpendicular line is just going to be 3. Finding the equation of that line then is y minus y1 equals mx minus x1, where the 2 I suppose is negative there, so 3x plus 6. A bit of a nicer one for us here, minus y plus 7 equals 0. Let's just test, is this point on this line again? So 3 minus 2 plus 7 minus 9 plus 2 plus 7, and that of course is equal to 0. So we've shown then that the center of the other two lines is in, or the center of the other circle is in fact on both of those tangent lines there. So quite an involved question, a lot of different parts being tested there. And even parts about tangents being perpendicular and all of that. And I suppose this is the thing with the circle, is that with the way we've set up these notes, there is, I suppose, we're trying to lead you through it to some sense, but there are parts that are kind of coming and kind of mixing between different parts here. So if there's bits there about, particularly about tangents that you're a bit unsure of, then I would go maybe to that tangent video and then kind of come back and kind of adjust accordingly here, I suppose. So let's look at another example. A circle has its center in the first quadrant, so that's always good to know. It means that the two x and y coordinates are going to be the same, or the same sign. The x-axis is a tangent at the point 3, 0. The circle cuts the y-axis at points that are 8 units apart. Find the equation of the circle. Okay, so we're just looking for the equation of the circle at these different points here. Okay, based on the fact that we know, based on, I suppose, what the information is that we know. So we know 3, 0 here is one of my points. Okay, we know 3, 0 is a point that the circle touches. It's a tangent point. I could sub this into my equation of the circle and kind of see where that takes me in terms of coming up with an overall equation for my circle. Rather than doing that, I'm just going to use, I suppose, the few limited parts maybe that I can kind of work with here. Looking at drawing a kind of smaller triangle for myself here. Okay, and we'll take this triangle out to the side. And this is kind of what I mean as well about some of the things that are coming in here maybe are more related to that tangent video as well. So that's probably one that I would come back before maybe attempting some of these exam questions. But no harm for us to run through them here anyway. But I have 8 units across on that axis intercept there. I know that my x coordinate here is 3, which means that I've gone a distance along the x-axis of 3, which will match up with this part here. And I know that this is my radius. Now I'm using the fact that the line perpendicular from the radius to another perpendicular line will bisect the chord of the circle. So that actually means that each of these parts here actually has a length of 4. Okay, each of these parts here actually has a length of 4. So taking that smaller triangle here, I have 4, I have 3, I have radius, and I have perpendicular. So my radius squared is 4 squared plus 3 squared. So 16 plus 9, so 25. So my radius is root 25, which is 5. Okay, since my circle touches the x-axis, then the y coordinate is going to match up with kind of that height of the radius here. Okay, so that's going to be a distance of 5. We know it's in line on the x-axis with that x point of 3, so the center there is going to be 3, 5. So I can then label my overall equation then x minus 3, y minus 5 squared equals 25. Okay, so less of an intersection question there and more of really kind of looking at the different equations of the circle there and the intersection with the axes, I suppose, that we did have earlier. So looking at one more exam question, then the point 5,2 is on the circle. Find the value of p. So to do that, we're just going to sub that point into the circle and see where it takes us. So 25 plus 4 plus 5p minus 4 plus 5 equals 0. So 5p equals, let's see, 25 plus 4 minus 4 plus 5 is 30. So p equals minus 6 there, I believe. And just rewriting now my equation of the circle with that to set us up for the next part. So minus 6x minus 2y plus 5. I'm told this line intersects the circle at k, or intersects the circle k. Find the coordinates of the point of intersection. So we're going to take that equation of the line and rewrite it. So x equals y plus 1, subbing that in for x, y plus 1 squared plus y squared minus 6, y plus 1 minus 2y plus 5. And again, just solving to get my overall equation there. Okay, simplifying all of this down, so 2y squared minus 6y equals 0. Okay, as it happens, it all just kind of cancels out a little bit there on us. Going to factor out 2y here. It's always good to kind of get practice of these sorts of questions. So y equals 0 and y equals 3. Okay, subbing those back in then, x equals 0 plus 1, so 1, x equals 3 plus 1, so 4. So 1, 0, 4, 3, the 2 points of intersection. Okay, so really looking at points of intersection here, the main thing coming up really is just being able to do those simultaneous equations. So we had, I suppose, the best practice of that in that long question from 2011. But again, it's a simultaneous equation, one linear, one non-linear. So again, it's another way that you could be asked that sort of question. Rather than it just being presented as kind of here's two equations, you're maybe more likely to get it in the format of circles and give kind of context to those equations there then that you're working with. So that's kind of the main thing, that idea of the common chord, making sure you can kind of go through the motions of getting the common chord for two circles and then using that to find the overall point of intersection, and that giving you good practice then of just generally finding your points of intersection anyway, and kind of looking at those tangents as well, maybe before we kind of look at those exam questions.